In this session, we are going to study the characteristics of algorithm as a part of the playlist of design and analysis of algorithms. In simply, we call it as DAA, DAA. What is the first characteristics of algorithm? That is the definiteness. There are various characteristics are there. As I mentioned, definiteness means that defined, that is called every step in the algorithm must be clearly and precisely defined. If it is not there, then it is not an proper algorithm. The second one is called there should be no ambiguity. That means and no ambiguity in instructions. What is the example for this definiteness? A step-by-step recipe. It is like example for baking a cake with exact measurements and procedures. If the exact measurements, if you don't follow, what will happen? That baking the cake, that cake will be spoiled. It will not come properly. Like that means the meaning is that when we are writing an algorithm, we should be very specific and precise. That is required. Those are the two keywords one has to follow. That comes under definiteness. Coming to second one is that finiteness. Suppose that algorithm should be finite steps of instructions. It is not infinite steps of instructions. Suppose if it goes to our loop, suppose it should not enter into infinite loop. If it is entered into the infinite loop, that is not called as an algorithm. Of course, the program won't be executed. But the finiteness means the finite set of instructions should be there. Number of steps should be finite. It should not be infinite. What is that kind of example? Finiteness, related to finiteness, that a sorting algorithm like bubble sort ends after a specific number of comparisons. It is not a specific number of comparisons. It is not infinite number of comparisons. So that is the second characteristics of the algorithm. The third characteristic is input. As I mentioned, input, that is the very important for input. That number of parameters, how many parameters should be there. So algorithms can take 0 or more inputs before execution. Then output can become the one of the characteristics of algorithm. All right. In the output characteristic, how many outputs are required? More than 0 output is required. At least one output is required for output characteristic of the algorithm. So input provides the initial data needed for processing. If the inputs are not proper, what will happen? The program processing won't be taken place. Now what is the example? A search algorithm takes an array and a target value as inputs. Suppose if you consider the inputs in the case of multiplication algorithm is there. In the multiplication algorithm, the output is 1. And how many inputs? 2 input parameters are required. Okay. Coming to the next algorithm, that is called output algorithm. What is the output algorithm here? Algorithm must produce at least one output. If it is 0 output, it is not at all algorithm. All right. So output result is the result of processing inputs. What is that? Suppose example, a division algorithm, if you consider it, how many outputs will come? Quotient and remainder. If we consider addition algorithm, how many outputs are? Only one output. How many inputs are? 2 inputs. That means we have to, in addition algorithm, there are 2 things, 2 parameters you have to addition it. Then only it will come out output, one output algorithm. Coming to next characteristic of algorithm is that effectiveness. Each step must be simple enough to be executed within a finite amount of time. It is not infinite amount of time. It follows what? Time complexity. It follows the time complexity. It should be reducing. It should be minimum time complexity should be there. Okay, the algorithm should be practically implementable. That is the effectiveness. Example, that addition algorithm, as I mentioned here. Coming to the generality. Generality means it should not be limited to for specific cases. It should not be limited to for specific cases. It should be a wide range of it should work for a wide range of inputs, not be limited to specific cases. And one more thing, generality is that it should be reusable for different data sets. Remember keywords for generality. If you want to write generality, it should not be limited to specific cases. Wide range of inputs are required. Example is that again, sorting algorithm should work on numbers, characteristics and strings. And seventh one is the uniqueness. The output must be uniquely defined for a given input. For uniqueness, what to be remembered? Uniquely defined. Uniqueness, uniquely output must be uniquely defined. The same input should always produce the same output. That is what a mathematical function always produces the same result for the same inputs. That is the uniqueness. Here the next 8th one is time complexity. If the time complexity is there, means comes under another characteristic, what? Space complexity. So the efficient design of algorithm is what? It reduces the time. Okay, that means time should be function of the input size and helps understanding the efficiency of the algorithm. But that is the example is that binary search has a time complexity of order log n, making it faster than linear search order n. Okay. That means this order log O log n means order log n. This is one type of what is that? We'll study in coming characteristics of algorithm, that is asymptotic notations. This is order log n, O n, order O n square, O 2 power n, etc. We'll study in coming algorithms. Now next one, ninth one, is the space complexity. As I mentioned, it should require what? This refers to the amount of memory required by an algorithm. Space complexity should be more or for efficient design of algorithm, or less? Less, should be less for efficient or effective design of algorithm. For both design of algorithms, it takes space complexity high and time complexity is also high. And examples for these space complexity: recursive algorithms require extra memory for function calls. That's recursive algorithms require extra memory. That means we should not, more memory means it is not effective design. The final one, that is correctness. The algorithm must produce the correct results for all valid results, for all valid inputs. It should handle edge cases, effectively. What is algorithm here? Example is that a pathfinding algorithm. What is that? Pathfinding algorithms, A star algorithm and also disk cross algorithm should always find the shortest route if one exists. These concepts will study in graph theorems, Kruskal algorithm, disk cross algorithm, traveling salesman algorithms. All these algorithms follows these characteristics. 10 characteristics must be followed, then only it is known as efficient design algorithm. Otherwise it is a poorly designed algorithms. Thank you for watching this characteristics of algorithm. I hope you understood better. Thank you. Bye bye.